Hi, my name is Dave Vance, and this video is about getting started with SAPP. We're not going to talk a whole lot here about why you would use the tool or what it's for. This is really just an overview to get you started, how to create the first input files, what data do you put in, and the mechanics of using the tool for the first time. In some other videos, I'll talk more about the purpose of the tool, how you use it to analyze a group of projects, and why it might be useful for you in terms of figuring out the branching structure for a Y-DNA project. But for now, this is really just about starting use of the tool and the data that goes into it. So if we look at what you need to get started in the tool, since SAPP's purpose is basically to recreate an ancestral tree that explains the STR mutations that connect a group of kits, it further constrains that by the available SNP and genealogy data. So you therefore need, first of all, the STR data for a group of kits that you want to analyze. It can't be just one, and honestly, 2 kits, the branching is not that complicated. So SAPP requires at least 3 kits, and it requires STR data of some kind. It can be of any length. It could be 12 markers, but honestly, there's not enough data in 12 markers to determine branching. So typically people put in a mix of 37 marker tests, 67 marker tests, and 111 marker tests. Of course, it seems that Family Tree DNA is about to issue 500 marker test data for big Y tests, and the tool will accept 500 as well. There's no length limit to the amount of STR data that you can enter. But typically, if someone has tested with Family Tree DNA, they will have the usual 37 to 111 markers, and you can mix those in as much as you want to within the tool. Optionally, you can enter SNP data for the same group of kits, and optionally, you can also enter genealogy data, so who shares a common ancestor perhaps within the group that is closer to present day than the common ancestor of the entire group, and that sort of thing. And we'll talk about how to do that in a few examples here. But to get started, in this video, we'll talk about 5 different things. One is capturing the Y-STR data. First of all, where do you get it from? How do you put it into the format that the tool needs? Second is creating the input file itself. It has to be in what's called text format. TXT is the extension. We'll talk about the sections at a high level. There's a lot more detail that we won't go into here, but I'll touch on the major sections and then just show you the other sections just for reference. We'll go through some example runs so you get familiar with how the tool works and how it uses the various input sections to create its trees. And then briefly I'll mention what SNP or genealogy data is important. Of course, in your project, you may have people that have done a big Y test or other NGS testing. You may have people that have done a lot of panel testing and have a lot of SNP data. The question is, do you need to enter all of that? The SAPP tool does not read BAM files directly or VCF files, so you have to manually put in the SNP and genealogy data. And it turns out that only a subset of the total test data is important for branching purposes, and we'll talk about that in a minute too. So where to find the STR data? The easiest place to get the STR data from is the results page of a Y-DNA project. So these are obviously very common. Most of us belong to one or more of them. They usually show the STR data in this kind of a format, sometimes all public, sometimes mostly private, so you have to have access to the data. Bear in mind, of course, this data is sensitive. Depending on the country you live in, it is subject to various privacy laws, so please protect it. That's why the SAPP tool does not retain any of this data in its internal memory or its internal databases. But if you go to this page and you have access to the data, you can select, like I did here, it's the first 4 lines, and choose copy from the browser that you're on, and then you copy that over to either the text file directly, or I usually copy it over to an Excel file like this. In this case, when you copy it to an Excel file, you want to avoid something that's called date translation that Excel does automatically, so the easiest way to avoid that is select Control A, which selects all of the cells in your worksheet, set the cell format to text, and then you can paste. I usually use with destination formatting if it matters, but that way you paste this information and you get all of the data in one place. You can work with it. So I have faded out the identifying information for privacy reasons. These columns are usually not used by the STR data section of SAPP, so you can either hide them or remove them when you're going to copy them over. But then you can select all this data. The kit number, of course, is important because that's one of the identifying information pieces for the individual kit's data. But this format over here, the dashes, the hyphens, the spaces or tabs, SAPP is actually fairly forgiving about those. You don't need to do that much translation on that data. So once you have this copied over, you can either copy and paste from the Excel file, or as I said, you can do it from your browser directly. And if you open up a TXT file, I'm on Windows. I usually use Notepad for this. You can use any editor that you like that can create text files, but don't use Microsoft Word because it has a habit of inserting special characters that it uses for formatting information, and that will not be translatable into either the raw text file or the SAPP tool itself. So use a different editor, but you enter /str data as the section header for the STR data, and you can see here I just simply pasted all that data straight into the TXT file. So the format again is important. If you've copied straight from the browser, you'll note it needs to have the kit number first, or some identifying number for that particular kit. And then the STR data just follows, can be any number of markers, but the data is important to not have other text information in here, any other identifying, no SNP information, etc. So be sure that you've deleted those before you try to copy these over. So besides the STR data, of course, there's a lot of other information that you can put into a text file. So let's talk a little bit about some of the sections. Here's another input file I've created. It's a little simpler in terms of the kit information that's there, but it has a number of sections that you may find important. These are some of the most useful sections as you create a file for SAPP. So I will highlight them so that I can talk about them in sequence here. And at the top, you've got some comment lines. These actually can be sprinkled out throughout the file. They don't have to be at the top, but if anything starts with an asterisk, it's assumed to be a comment and therefore ignored. That tends to be useful, so you can annotate your file if you want to put some additional information about what the file is for, why you're using it, who the group is, and so on. Then you have the /str data, which is the section that talks about all the STR data. That's what we just talked about how to create. Then you have something called /snp data, SNP data, which gives the test results. Now this is manual entry. You just repeat the kit numbers so that it can cross-reference the SNPs with the STRs. And you give it individual SNPs and whether that particular kit is positive. You can also say it's negative, or you can put a question mark for unknown. Now, SAPP will automatically assume that if you don't put a SNP in this list, that it could be unknown. And the reason for that is because not everyone is tested to the same level. Someone may have done a panel test where someone else has done a big Y, and it's possible that kits are positive for SNPs that they haven't tested for yet. So the default, if you will, for a SNP that's not included in the list is unknown. Then you have the gen data section, which is where you put genealogy information. In this case, what you're really specifying is ancestors of subsets of the group that are really more recent than the common ancestor of the entire group. So here, for instance, I'm saying that there's a Matthew Smith, and I just put in the text that he was born in 1790, but the tool wouldn't care. It's just a label. And that ancestor is an ancestor of kits 2, 4, and 3. You can put them obviously in any order. I said that they were all positive. You can also say that someone is negative or question mark, which means I don't know, or I know he's not a descendant, but you don't have to. The default in this case for genealogy data is that if you don't specify a kit in this list, they are assumed to be not an ancestor, so they're actually negative for being an ancestor, a descendant of that ancestor. And then this is a /info line, which is where you again repeat the kits and you put any other information that you want to put into the boxes that are related to that particular kit. So if I put Smith here and Smith, Virginia, that will be added into the box on the chart so that I can have a handy reference for names or other information that's important about that kit. It will by default put the kit name. Bear in mind, if you put an info line in and you're putting identifying information in, that may make the chart itself more private than you want it to be. So be careful about the information you put here if you want to make this a widely distributed tree. Now, there's a lot of other input sections that you can use. This is the inputs screen off the SAPP tool that gives you all the information about all the various sections. I'm obviously not in this video going to go into all of the other sections that are optional that you can use, but if you go here, it will have an explanation of them. As you start to use the tool, if you want to try some of the more advanced options, you can do things like change STR mutation rates. You can specify lots of different ways to calibrate the tool's performance. If you look here, there's a link to advanced inputs where you can get an explanation of all those types of inputs as well. They do have a much bigger impact on the tree itself than a lot of these other ones do, but they also obviously change how you think that the history has gone. So I would say use them judiciously. It can have a big impact on your tree, and you don't want to make the conclusion that your tree is correct simply because you've told it that that's the way you want it to reflect it in the first place, right? So anyway, that's just my warning about the advanced inputs, but if you want to learn other sections and how to use them, there are things in here that are used for just pure cosmetic reasons. You can change the colors of boxes, you can do things that change how the tree is presented. You can override certain functions, you can add the information on the tree that's not normally there. So there's a lot of good sections in there that you can use, a lot of good options that you can put in order to tailor the tree, both in the analysis as well as in the presentation for how you want it to look. Let's take a look now at some example runs. So I'm going to go back to just having STR data for a minute. This first run, we'll talk about 4 kits. The first 2 have only 37 markers tested. The second 2 have up to 67 markers tested. It's obviously a simplified run, but it'll show how the tool works and what it uses all these for. So if I just create one section in my input file, this is all I need really for STR data. Do /STR data. I can call the file anything I like. I do /STR data. I copy in the 4 sets of STRs, and they can be separated by anything, spaces, tabs, delimiters, as we've seen. They do need to be in the same sequence though. They can be any number of markers, but you need to have the same sequence of them so that SAPP can tell which STRs are which. You can actually rearrange the order of the expected input through advanced inputs if you want to. Normally you have no real reason to do that, but it's possible. If there are major gaps, if you have someone who's tested only 1 out of the 67 markers and it's much later in the sequence and they only have 37 first and so on, that can be a problem to mix together. So that's a little more of an advanced topic. Right now we're just going to focus on them all being in the same sequence, and although they can be any length, any number of markers. So we go on and we are going to plug this into the tool itself. So you go to the web page for the tool, which is here if you don't have it. You click on Choose File, which will bring up a way to get to any file on your hard drive. You go to that file and select it. It will reflect the file name here, and then you click the Execute button down here and it will run the tool. It usually goes fairly quickly. If you have several hundred kits, it will take a little bit more time. The longest I know of is about a 550 kit input file that takes about an hour to run, a bit less, and but it will give you regular status messages while it's running so that you know how far it has gone and how much it still has to take. So the output consists mainly of a set of tables first. So this first table up at the top is a repeat of the STRs that you entered. It will show you, so we have the 4 kits here and we have all their STRs. The first 2 are only 37, then the second 2 are 67. It will calculate what's called the group modal haplotype on the top, which is the most common frequency of the numbers down below, and it will show you the off modals, either lower in blue or higher in red, against that modal. That's a very common way to show the kits and reflect the changes in the kits. You'll see that on the family tree DNA results pages for the colorized version and so on. So that's the same reflection of that information there. Then it calculates the original genetic distances. These should match the genetic distances that you get from family tree DNA or somewhere else. It shows the cells in different colors because they have a different number of markers. So if you're going to compare genetic distance, it's important to compare the same number of markers. Obviously, a genetic distance of 6 on 37 markers is not the same as a genetic distance of 6 at 67. So this is an easy way to reference the number of markers associated with that genetic distance by the color of the cells. Then it calculates what's called the adjusted genetic distance. Now this is particular to SAPP. It turns out that genetic distance itself may be prone to something that's known in the community as convergence, which is that the STRs can change over time to look the same in your kit or someone else's as another kit and make it look either closer or farther apart, when in reality that's not the way the mutations actually happened. So what SAPP does is it tries to unravel that. It calculates how the mutations have happened on the branching, and because of that, it may recalculate some of the genetic distances. If that happens, it will show them in red. So here we have a 6, whereas it was 4 before, and I'll show you on the tree where that comes from. Now, after the run is finished, at the bottom of the run, you'll see a button that says Get SAPP Tree. If you press that button, it will show you the tree that we'll see on the next slide. So here we have an output tree from SAPP. The kits that we entered are reflected at the bottom here in yellow. I should say the tree is not in time order. You will not always see all of the kits reflected at the bottom like this. This is a simplified view. But the SAPP will try to produce the tree in the smallest size possible, so it will sometimes put the kits up or down the tree where they make sense, where they can fill in the white space that's available to the program for charting purposes. And the reason for that is very quickly, as the number of kits increases, this particular picture can get very large. I believe on the 557 kit input, that's the largest that I know of, if it were printed, it would end up being 4 feet high and 100 feet wide. And obviously that's too big for anybody to usefully process it. But even for smaller size groups of a couple hundred or 100 or more, this picture can get very large. So SAPP tries to minimize the space, and you'll see that the charting is not done on a time order, so be aware of that when you look at this picture. But the format itself is fairly simple. You have the kits at the bottom. They go up into branching nodes where there's a common ancestor for these individual kits, and then they end up with a group MRCA. MRCA stands for Most Recent Common Ancestor, and that is the starting ancestor for the entire group. Now, each of the nodes has a TMRCA associated with it. That stands for Time to Most Recent Common Ancestor, which is the estimated date for when this branching occurred. Now, it is estimated. These are very, I'll say, broad estimates because they're based on the mutation rates of the STRs, and nobody's individual tree will perform exactly to statistical averages. So please take them with a grain of salt. But it gives you the TMRCA first in the number of generations with an error range, and then it translates that to a time, again with an error range for when that probably occurred. In between the kits and the nodes themselves are the mutation history for the STRs that have occurred along those lines. So when SAPP has put this together, it says I've got 4 STRs that have mutated here from, in this case, from 30 to 31, from 17 to 18, and from 17 to 18 again. And each of these 2 kits have those in common. So that's what we like to call a signature for STRs that really defines a subgroup that, from an STR standpoint, clearly has a common ancestor because of that signature that they have in common. And then along each of these lines, there were a further mutation on a different STR for each of these that occurred. Over here, we have a common signature of just one STR, which is a little weaker, but still suggests that these two kits are a common set underneath a common ancestor, I should say. And then again, each one of these has a set of mutations which have occurred. Now, I will point out that there's two here that actually happened in parallel. So the same STR, which is 456, has mutated from 18 to 19. So normally you would see these two as closer than they really are because they've both mutated to 19, and SAPP has decided that those were parallel mutations instead of being a mutation from a single common ancestor. The reason for that is because 456 is a faster STR mutating marker than either 442 or any of these up here. So SAPP decides that that's not strong enough to be a signature, certainly not compared to the other STRs that are on this chart, and it has split them up. And that is why, if you remember back at the adjusted genetic distance, it is said that the genetic distance between kits 2 and 3 is actually longer, or I'll say greater, than the genetic distance that would be calculated normally, because it has concluded that there's been a parallel mutation, as it's called, that can make the normal analysis a bit more complicated. I'm going to switch over now and do a second run that takes the same 4 kits, so the same STR data, and adds SNP data and genealogy data to it. So in this case, I have a /SNP data line. I add as many of the kits as I have SNP data for. It doesn't have to be the same number of kits, but it has to be the same kits themselves. And I enter any of the SNP information that I think is relevant to determining branches for these individual kits. So in this case, the first 3 I've said are going to be positive for L21, L513. They're all positive for Z23519. And the first one is positive for Z23516, and the other 2 are going to be negative for that marker. Now, I only have one SNP for this last one. I know they're 513 positive, and I did this in part to show you that the parentheses are optional. You put the parentheses in mostly because if they span several lines, then SAPP can track which ones are associated with this particular kit if it goes on for several lines. But otherwise, you don't need them. For SNPs, as we said, if you put positive, obviously that means that the SNP was found to be positive. If it's negative, that SNP was negative. And if it's question mark, then it's unknown. But the default is unknown, so you don't have to put that in. So for instance, for kit 4, it's unknown for Z23519 and unknown for Z23516 because we only know one single SNP marker result for that one. In the genealogy data, I've said that kits 2 and 3 are descendants of John Smith. That does imply, as we said, for genealogy data, that kits 1 and 4 are not descended from John Smith, that only 2 and 3 are a common descendant from that particular ancestor. That's how I've defined it here. I can put a question mark if I don't know, and we'll talk about that in a minute. But in this case, this is going to be interesting to see how the tree reacts, because if I go back to this chart for a second, kits 2 and 3 were the ones that were found first to be on completely separate branches. So I've said, actually, these 2 kits are more closely related to each other than they are to kits 1 and 4, and we'll see how the tree reacts. So first, we see the tree itself, and here's a completely different tree. And it's done this mainly because I've said John Smith, who now is reported for this node, he's the common ancestor of these 2. Kits 2 and 3 have to be descendants of John Smith, whereas kits 1 and 4 are not. Now, kits 1 and 4 no longer show enough of a common pattern to be able to put them under their own branch. They're both going to be separately lines into the group ancestor. And I also have reported the SNPs that I put in, so L21, L513, Z23519 are all reported here. The only kit that's positive for Z23516 is kit 1, and because of the way the tree is drawn, it doesn't look like anybody else is likely positive. Now that could end up here, of course, but since I know that kits 2 and 3 were actually negative for 16, that means it has to sit here, because if it were any higher, then those two would be positive for it anyway. So the SAPP tool does that kind of analysis to tell you where the SNPs have likely been, where they actually have been caused on the tree that it draws. That's why it puts them in the various boxes. Now, you'll note again, this is not in time sequence. These are all 4 of these kits are actually present day people. And it's simply put them on the tree where it is the smallest possible picture. But it has also flowed the mutations to match the tree. So in this case, it says, okay, well, if 2 and 3 share a common ancestor, then this 456 mutation that I thought was a parallel mutation before actually is a signature for that. But now I have these 3 mutations, 449, 576, and 570, that have each occurred independently on different branches. That's unlikely, of course, from a statistical standpoint, but because of the genealogy data that I entered, SAPP will force the tree into that configuration because it assumes that the genealogy data is correct. It will not override that. Now, if we take a look at the table output, that's just the fact that those are now considered parallel mutations. And if I go to the actual table charts, I again get the exact same table of STRs. I get the same original genetic distance. Now my adjusted genetic distances have changed. In fact, this genetic distance between 2 and 4 has gone from 2 to 8 because of those parallel mutations that it says actually it must have happened because of the way that my genealogy data was entered. Now, once you get to use SAPP for a while, you start to be able to look at the original genetic distance versus the adjusted, and start to pick out kits that the change in the STR mutations between them looks unlikely or looks like something that you want to look at a little bit further. So this is one tip that's a way to analyze your tree, is to compare those two. But SAPP also produces another table that includes both the SNPs and the genealogies as a cross-reference to all the kits that I entered. So it knows that these are positive, and obviously the red dash is negative. For the genealogies, it says whether someone is either not a descendant or a descendant. And in 2 cases, these are unknown for kit 4. Now, if you remember, I said that kit 4 was positive for Z516, for L516 rather, but I didn't say anything about L21. SAPP has figured out that kit 4 has to be positive for L21 because it has an internal SNP tree, and it knows that L513 is downstream of L21. So any kit that was positive for L513 is by definition positive for L21. So that's what the internal tree is used for. You could specify L21 as well, but if you don't specify, and if SAPP has that SNP in its internal tree, it will be able to fill in those markers for you. In this case, though, these 2, which actually are in the internal tree as well, happen to be downstream from 513. So SAPP says, well, I don't know if those are positive yet because all I know is that this particular kit is positive for the higher SNP. So anything above it is by definition positive, but anything below it is still unknown. Okay, so let's try a third run. But in this case, we're going to say that we're not really sure that kits 1 and 4 are not descended from John Smith. You know, perhaps their paper trail doesn't reach quite that far back, but they might be. They're in the same area. They certainly could be descendants of John Smith. They just don't know that if they are. And since SAPP has assumed that they're not, let's change that assumption and say that perhaps it could be. So now I'm starting to have taken the analysis from my first run and looked at the tree and said, well, the mutation history doesn't quite make sense. I don't think all of those were parallel mutations. I'm going to start to adjust my inputs, you do have to be careful. If you adjust your inputs for a foregone conclusion and the tree reflects that conclusion in your output, you don't want to say, therefore, I've proven my case, because all you've done is you've told SAPP to reflect the same output that you've given it as the input constraints. But in this case, the STRs seem fairly conclusive. It's doubtful that the kits 2 and 3 are going to be descended from a later common ancestor. So let's start reflecting the genealogy the way that we think it probably looks like for real. So now I've put kits 1 and 4 in as question marks. And if you look up here, so that's the question marks, and if you look up here, it's reflected these as question marks in the tool. This is the output table that I just copied in here for simplicity. When you run it, you get this output. These are now question marks as unknowns, whereas before, if you remember, they were marked as not descendant. So what we get from that is the tree's back to what it was before. And now if you look up here, it says John Smith is the common ancestor of all of these. So SAPP has made the determination itself. It has predicted that even though you put question marks there, because of the configuration of STR mutations, and in particular this strong signature here, and even this one here, which is a fairly slow-moving marker, that this is the configuration of the way that the ancestry should look. We're going to try one more run, and that is with a little bit more uncertainty. And now I'm going to go back to the SNPs and say, well, I told SAPP that kit 3 was negative for this marker, but it turns out maybe the call wasn't good enough, it was low quality, or perhaps they didn't really test it. I just either transcribed it wrong or had the wrong assumption, and now it's a question mark. I could just leave this off because that's the default. It would assume that it's question mark if I don't include this SNP in here. But for explicit example, I've now put it in as a question mark, and you'll see that this SNP is reflected now up here, whereas before that was negative. It's now said in the output table that it is a question mark. What happens here? Well, if you remember before, kit 3 was actually known to be negative for Z23516. So it was impossible for node 6 here to be positive and have a descendant that was negative. Well, now that 3 is potential for Z23516, I have what's called a potential range of SNPs here. If 3 is negative, then the SNP is only found in kit 1, and it's a private SNP to kit 1. If 3 is positive, then of course it has occurred up here, and Z23516 is actually a common SNP for both of them. We don't know that yet from the results because it's not conclusive. So what SAPP does is it puts a range here with the brackets from here to here. This SNP could have occurred. So when you see a SNP reflected in the tree twice with this kind of convention, that means that's the range. Now, they could be very far apart. In this case, we know that 516 is not any higher because kits 4 and 2 are, I believe kit 2 is still entered as negative. So if kit 2 is negative, that means that this whole branch can't be positive for Z23516, which means that the group MRCA can't be positive for 23516 either. So it could only have occurred here or further down. So that's the kind of analysis that SAPP does on the SNPs in order to put them on the tree and give you a view of where they fall on the tree in order, so that you kind of see if you're going to do further testing, you can get a sense for where you need to target that testing, who needs to test for what, so you can maybe narrow down those ranges a little bit further or determine who is positive or negative and help to constrain the tree a bit further in order to calculate those ranges a bit more precisely. All right, so I've talked about the circled SNP labels, and I'm going to go on now to say, as you enter SNPs, you notice I only put 4 SNPs into this tool. What SNPs or genealogy data is important? Obviously, if you have a group of kits, they probably have thousands of SNPs that they're all common for. The anthropological time frame reports a lot of SNPs. They may be M269, they may be U106, they may be L21, they may be I2E. They all have SNPs that define them back, thousands or tens of thousands of years ago. Those are not going to be terribly useful to put into SAPP because they don't help to define the branching. If all of the group is common, if all of the group is positive for a SNP, then obviously there's no branching information that can be determined from that SNP. So for instance, the green up here, this green circle says that the SNP is common to all of them, and the green explanation is that SNPs or genealogies, both, that are common to all kits in the group are not particularly useful. You could say that a common ancestor, if you knew who the group common ancestor was, you could put in a gen data line that simply said they're all going to be descendants of that common ancestor, and all that would do is it would put that ancestor's name in the box at the top, which, if that's what you want, that's fine, but that's really just a labeling convention at that point. It's not helping the branching at all. On the other hand, if the SNP is too small, if it's known to be a private SNP, if you know for some reason that a SNP is private to a particular kit, that's also not useful for branching purposes. It'll never be found positive in any other kit, so it's not useful to help constrain the tree between the kits and the common ancestor. Whereas the red, so a SNP that at least two kits are positive for, and that may be either are tested positive or suspected positive. You can still enter you can still enter SNPs that may have been found in just one person, but that you suspect may be common to some subgroup, and those will be used for branching if SAPP can determine where on the tree they're likely to have been formed. But those are the SNPs that are really the most useful. So it does depend on your subgroup. Obviously, smaller subgroups may have fewer SNPs to put in. The general rule that I translate all this to, if you look at the bottom here, it says a general rule is you only enter SNPs or genealogy data that you know or suspect which at least two kits in the group are positive for. So it has to be more than one, but at least one other kit in the group is negative, so you know it's not a common SNP to the entire group, or that it's not a common ancestor of everyone. So those are the ones that you really want to focus on. You want to pull out of their information just the SNPs or genealogy data that are helpful in determining the branching or in mapping this. Now, obviously, with 3 or 4 kits to show on the tree, it's not terribly complicated of a tree, so there's not a lot of information that's going to help the branching. Once you get into the 20, 30, 40, 100, 200 kits, that opens it up to a lot more SNPs you can put in that are common to subgroups of that set of data. So in these simple examples, it's not terribly useful, but once you start adding in the information for a larger group, it becomes a lot more useful to determine the branching that way. The last thing I'll talk about in this introduction is just a page with a lot of the other most common optional sections that you can put in. So they fall into 3 general areas. Once you've had the STR data, the gen data, and the SNP data, you can add to this. So some sections are for adjusting how the tree is calculated. You can specify a different modal. If you remember, SAPP calculates one, you can override that. You can tell it to ignore certain STRs. You can calibrate dates on the tree from an MRCA standpoint. You can set certain STRs to values in certain places if you like. You can enter your own SNP tree, so you can, if you remember, it uses the internal tree to calculate other positive and negative SNP markers than the ones you've entered. You can add to that internal SNP tree just for your run. You can change the STR order. There's a lot of options that you can put in to tailor the how the tree is calculated as well. There's also more data that you can show. There's show modals, there's show mutations, there's different ways that you can show more data than what the tree is reporting in its simple approach. All of those are on the inputs help page as well. And then there's simply cosmetic things. The info line we talked about is simply a way to add more information into the boxes for the kits. You can also change the colors. You can add more information by groups, and then you can move things around. You can even throw away the graphical output entirely and produce the entire tree as an indented text output, which is beyond the scope of this video, but if you want to see that, you can play with the text out option, see what that looks like on the input help page, and try that and see if that makes sense. So that's the introduction to SAPP. I hope that was helpful in being able to build your first input text file. Again, if you have any questions, my email is found on the SAPP tool help pages, and you can contact me that way or get started, and I hope it's useful to your group. Thank you very much for listening.